Kyla, do you mind if I do a quick introduction and welcome to everybody?
Yeah, yeah, that'd be great. Thank you.
All right, cool. Okay, well, hey everybody, welcome to our second webinar in this flocculant series from Applied Polymer Systems. Glad everybody could join us today, and we are able to record this, so uh, we've got that going, and we'll be able to put that on the COSWA YouTube channel later. And Kyla has also agreed to get us a recording of the information from the first webinar as well. So we're going to have both webinars and hopefully the third as well on our YouTube channel for COSWA. So with that, Kyla, whenever you're ready, please take it away.
Sure. Yeah, I'll go ahead and get started. And then if a few people pop in here, that'll be fine. Yeah, so thank you all for joining me. I'm not sure if all of you attended the first presentation, but if not, this is going to build on the fundamentals that we went through in the first meeting that we had. But if you did not, this is still going to be beneficial. We'll go through an introduction briefly to the flocculants that we're discussing that we discussed more in depth previously. And then we'll really focus on the applications, and some of them will be, we'll repeat some of the applications that you saw in the first presentation, but we're going to talk about them more in depth and kind of exactly how they work and look at some example case studies of how we pulled those together in an actual project. So I will go ahead and get started. As I just mentioned, we're going to do a brief recap, and then flocculants are used for a lot of different types of applications. I've split them into kind of two categories. We have, okay. So we kind of have two categories where we have flocculants for erosion control and kind of terrestrial applications where we're preventing movement of sediment off of slopes during rain events. And then we also have our use of flocculants, the granular types, to enhance our existing sediment and control BMPs. And then we also have the materials that we use specifically in flowing channelized water for water treatment. So I kind of put them in three different categories of flocculant, specifically polyacrylamide use. And so that's how we'll break it apart today and look at some of those different types of applications. So again, why are we using flocculants in the first place? We talked about this last time, but we have a lot of traditional BMPs. They can't remove those really small particles. So things like silt, clays, and metals will blow right through our silt fences, right through our check structures. They can stay suspended in the water column for weeks or even months, depending on the type of clays you have. Those materials, the sediment, they can transport pollutants, nutrients, and those eventually reach our water resources if we can't stop them and keep them in our disturbed areas. So those can have quite a few consequences. And of course, in addition to that, we have our consequences of project delays and fines and things like that. So our solution is to use flocculants like polyacrylamides to enhance the existing BMPs and solutions that we currently use in our projects. So why we use polyacrylamide, as we discussed last time, there are lots of different types of flocculants and chemical treatments. The most widely used one for what I like to refer to as passive treatment, which is the use of these materials when gravity flows or on the soil, or maybe we use pumps, but we're really doing these as kind of a passive application of these materials and letting them do the work. The reason we use polyacrylamide in those types of treatments is one, because it's very, very safe for aquatic organisms. We're using them out in the open environment. We want to make sure if they get loose, they're not going to hurt anything. So polyacrylamides have a very low toxicity. They're safe for aquatic organisms. They're food grade, drinking water grade. They're safe for people. And as we mentioned before, they're also very effective. These are very large polymers that can bind many different particles at once, form these big, heavy flocks that can then settle out. They take the things out we're after, like clays, metals, and even some nutrients. And again, as we discussed more in depth last time, there's over 70 years of use and research on these. So lots and lots of data and information on their safety and their efficacy. So that's why we use polyacrylamide in these. So we talked before, there's a few different forms of polyacrylamide that we use, and depending on the form, it can vary which types of applications we use them for. So we have our silt stop powders, or our granular form of the polymer that's used for erosion control. You can also use it for water treatment, but for our erosion control and soil stabilization, you're mostly going to be using silt stop powders. We also have a liquid emulsion form of the polyacrylamide that some people do use that for water treatment, but we specifically limit that solely to terrestrial applications because it can have some surfactants that have some toxicity associated. So the liquid emulsions are primarily for dust control and erosion control. We also have the flock logs, those hydrated logs, these little blue blocks that we see here in that first picture, and those are designed specifically for water treatment in channelized flowing turbulent water. There's also a pond log, which is again the same type of material, but it's used with aerators and fountains and things like that in flowing water. So those are the primary types of PAM products that we have, and they're, again, as I mentioned, used for different types of applications. So we're going to go ahead and start with looking at some of the applications of the PAM for erosion control, for holding dust and soil particles on site to prevent erosion and turbid runoff. So we talked a little bit about this before, but the benefits of using PAM is not just to hold the particles in place to prevent erosion. It was able to bind not just the soil, but if you have like a mulch mix or a seed mix, you're trying to establish vegetation, it'll hold the seed. Fertilizer, if you're using it with the soil, holds everything in place so that you don't apply all of this material, try to get vegetation established, and you have a big rain event that washes all of that investment down a slope. And so it'll hold all those particles in place. It improves the runoff clarity. And then in addition, it also improves water infiltration into the soil. So all those things combined, as we discussed before, actually improves vegetation growth. One thing about PAM is it only binds the very top surface layer of the soil. Again, it allows water to infiltrate, so it's not like some of those other surface sealing tackifiers that kind of, make water flow over the top. But the thing about it binding the top surface of the soil is that if you, I'm sorry, what's the term? If you disturb that soil, then you may need to reapply, because if you churn up that soil, or if you're driving over the top of it consistently, then you can kind of, break up that surface layer and that binding of the PAM. So it's important to note that it only binds that the top surface layer, and disturbed areas do need to be reapplied. So is it applied alone? Now, what we specifically tell people is that chemical treatments and polyacrylamides are not supposed to be replacing your existing BMPs. Now, it should almost always be applied with some other type of material, whether it's mulch or straw or matting or some type of other cover that is very erosion resistant and long-term solution. It can be applied alone because we do have some situations where we don't need a long-term solution. Maybe we have a stockpile that we need to stabilize temporarily. Or again, if we have dust issues, you're not going to put matting down for dust control. So if you apply it for dust, it doesn't completely, erase the need for watering, but it significantly decreases the amount of water because it holds those soil particles in place and holds some water on the soil surface. So if we have temporary stabilization, stockpiles, dust control, there are a few select applications where you can apply the polymer itself. So the polymer can be applied as an emulsion for dust control and soil stabilization, and that would be used either in a water truck or something like a hydro seed. Here we can see it in the water truck. So those are some easy application methods. You don't need to apply it separately. You can add both the granular PAM and the liquid emulsion as the last additive in a hydroseed or water truck mix. It is important to have a mixing unit in that truck to make sure it's fully mixed up. And then there is a limit on how much you would put in. And this information will be available later, but it's just some important points I want to touch on is if you are doing doing a hydroseed application, we use a maximum of 10 pounds of PAM per 1,000 gallons of water, because what happens is when we mix the PAM and the water, it can get so viscous. If we use too much PAM in the water, you can form this very thick, viscous material that can clog equipment. So it's important to make sure that you're following labels of any manufacturer when you're using the material. As I mentioned before, it's really applying with cover is going to be the best application for erosion control, because you're going to have a very long-term application. And if you're establishing vegetation, hopefully that would be your final application, and the PAM can help enhance the matting and those other mixes. As I mentioned before, it's not just about erosion control, it's about improving. It holds the nutrients, the microbes, all the things that vegetation needs to establish and grow. It keeps those in the soil where they need to be. So we're actually improving growth characteristics when we're using PAM in these applications. One of the applications that we use in, many different projects, it's not just erosion control, but what we'll talk about here quite a bit moving forward is something that we like to call soft armoring. So soft armoring the purpose is to create this erosion resistant surface, improve the water quality of discharges, and then bind these clays, metals, all together into this matrix. So what soft armoring is, if you remember from the first presentation, is the addition of the granular polymer with the matting. So if we use matting alone on a slope, with the absence, we can see a lot of erosion occur because the matting is not necessarily bound to the soil surface, so it can erode from underneath. When we use that site-tested type of polymer that we know will react with that soil, it's going to form this matrix between the soil surface and the matting, and it's going to hold it in place. So it's going to prevent erosion while improving the clarity of that runoff, because those fines can't be mobilized in the surface water and they'll remain in place. Excuse me. I think I may have had a cold during the first presentation as well, so I'm sorry. It's like all these little kids in my house. It's just a constant cycle. So what happens again is it forms this matrix where we have this long polymer chain that binds to the soil, binds to the matting. Again, if you recall that really fibrous material from natural mattings like coconut and jute and things like that, it forms a great surface area for attachment of those polymer charged particles. So it holds them all in place really well. So we're going to use the polymer to enhance those mattings, and it's a really great application. So it's a pretty simple application as well. Basically, if you apply the polymer by itself, as we mentioned, it's not permanent. It may only last a few large rain events before it needs to be reapplied. But if we again apply it with the matting or we're establishing vegetation, it can be permanent. We want to make sure that we prepare the site. Really, the biggest things to make sure when we're doing this is that if we are applying with some type of matting, if it is, an open weave jute or something like that, it doesn't matter whether we apply the matting or the polymer first, but we need to make sure that the polymer can contact both the soil and the matting. So if you have a closed weave or tightly woven mat, then you're going to apply the polymer to the soil surface and then put the matting on top so that it can make sure that it's able to attach between the soil and the matting and form that matrix. Besides that, it's pretty self-explanatory there. We apply the polymer, we apply the matting or the hydroseed, and we can help establish vegetation. So this was actually outside of one of our facilities down in Georgia. You can see a pretty steep slope. We did a polymer enhanced soft armoring application to stabilize that when we were doing some work there. And within 4 weeks, we had really rapid vegetation establishment. So even, steep slopes, this is a relatively, effective and erosion resistant application. So Now what I want to move on to is using the silt stop or the granular PAM for enhancing some of our sediment control BMPs that we regularly use. We touched on sediment retention barriers. It's basically a souped up silt fence, so we'll look at that in just a minute. I'm also going to talk about enhancing our different types of check structures with the flocculant, and then also a lot of projects are required to use dewatering bags or sediment bags. And so there are, I don't want to say there's right ways and wrong ways to use flocculants with dewatering bags, but we're going to talk about that because that's a pretty common BMP that we enhance using the flocculants. So first of all, the sediment retention barrier is again those two rows of silt fence that have the straw or mulch in between, and it's layered with the site-tested form, the granular PAM or silt stop polymer. And so what this is for is the silt fence, of course, is for sediment control. We want to kind of slow the flow, pool it, let those larger particles sediment or settle, but our smaller particulate are going to move right through that silt fence. So our clays, our silts, even our fine sands are smaller than the pore size in most silt fence. And so a lot of those small particulates, we can still have a pretty high turbidity moving through a properly installed silt fence. And so what we're doing with our sediment retention barriers, we're putting those two layers in and we're enhancing them with the granular form of the powder. And so what happens is by treating it with the polymer is we're able to flocculate out those fine particulates. We have that mulch or straw matrix in the middle that collects those particulates. And then the second layer of silt fence is kind of our final barrier to prevent, to capture them. And so you can see we kind of had this slow moving flow here of water. I'm going to see if I have the front side picture. I don't. So we have this slow moving kind of high turbidity water on the left side of the silt fence. It moves through, it reacts with the granular polymer, starts collecting on the straw that is in between there. And then the final row of silt fence, you can see there's some sediment collecting at the base of that. So that silt fence is still collecting some of that flocculated particulate. They did put a little bit more jute matting down along the backside of that as kind of a final line of defense. And then we have our clear water flowing off. So it's a great way to really enhance a silt fence and turn it into a water clarifying device. Depending on what your rules are, you might be able to, some places you're not allowed to use a flocculant unless you have, a buffer zone, a sediment basin, or some type of particle catchment. So depending on, the state rules of where you're at, depends on where you can put these, but a lot of people will use these as kind of a perimeter defense to be a final line for water clarification. Polymer enhanced check dams or check structures. This is a really, really common application. So essentially, again, the same principle as with the silt fence. If we have rock checks or wattles or, even filter rolls or things like that, those still aren't going to be able to take out our really fine particulate. So what we can do is for our we can enhance these using polymer enhanced soft armoring or potentially just the polymer itself. So for the check structures, with that rock, those will settle our large particulates out. It's going to kind of slow the flow, let it pool. What it's not going to do, again, is take out those fines. And so what we can do is we can use our polymer enhanced soft armoring technology, which again is just some sort of fibrous matting. We're going to treat that with the flocculant. And now as the water moves through there, it's going to react with the polymer. The sediment, especially if you have multiple rows of these check structures down your channel, then those flocculated particulate will collect on the jute matting and it'll form this into a water clarifying device. So this is just a picture of a polymer enhanced check dam. So we can see we have the jute matting on top. It's been treated with, again, the site tested granular PAM. And this also has a flock log, a couple flock logs on a stake in the channel as well. Typically you would space those a little more robustly in a channel, but since they've also treated this with the granular polymer. You know, one of the benefits of using granular PAM with the solid log form of PAM is the granular PAM is going to react very, very quickly. And it can actually be more effective in many cases, but you have to reapply that about every ½ inch of rain. And so the flock logs, they react a little bit slower. They can dry out between rain events, so it can take, 15 minutes or so to rehydrate once the water starts flowing. So if we use a combination of the solid log form and the granular PAM in these type of applications, we get our fast acting polymer, and then we also get our long lasting polymer. And both of them will work by themselves, but if you want, really high clarity and really, the best results you can, we like to use the granular with the flock logs, especially in these channelized applications. So with check structures and channels and things like that. North Carolina State has done a lot of research using wattles specifically with the granular type of PAM. That's probably their favorite PAM application that I can gather from the research and presentations that they've done. So this picture actually came from them. Applying the polymer to a wattle is really simple. We're going to apply it to the matting above the wattle. We're going to apply it to the wattle, and we're going to apply it below the wattle. And typically each check structure, the way that we dose the flocculant is based on expected flow through that channelized area. And so if you tell us that, we'll tell you, how many pounds of polymer you should use, based on how much water. Sometimes a kind of an easy button that NC State often suggests is using a 1/4 cup of flocculant per wattle. I like that because you're not going to overdose with that, and it is a relatively simple way. Sometimes though, if you have a large channel with a lot of water, or maybe you don't have that many check structures, you can also potentially underdose. So a 1/4 cup per wattle is a good place to start. But if you want to dial that in more, which we typically do at APS, we'll ask people to give us some more information about their channel and their flow rate, and we'll give you a site specific application rate for your treatment setup. So with that, again, right there, we talked about some check structures, our sediment retention barriers, and our polymer enhanced soft armoring. And so what I want to do is look at our first case study. I'm from Marquette, Michigan. We've got people all over. We've got Florida, Georgia, North Carolina, and Michigan. So I'm up in Michigan, and this was a project that was in my backyard. This was the Salmon Trout River Bridge. I like to use this project. They used a combination of sediment retention barriers and polymer enhanced soft armoring in a very ecologically sensitive area. And so the Salmon Trout River, it's in the Upper Peninsula of Michigan. It's a one of the only streams that supports a special type of brook trout here in Michigan. And so what happened is they were widening a roadway for a mine that was going in. And so when they redid one of the bridge crossings, they had a lot of sedimentation into some of the surrounding wetlands and tributary streams. And so it was kind of an uproar. So what we did is we went in and we implemented this treatment train of a couple different polymer enhanced BMPs. And so this was in a remote area. We wanted to do things with as little infrastructure as possible. And we're replacing this bridge, kind of right on the edge of this small tributary, small but important tributary. So you can see in this picture, this was the beginning of construction over the Salmon Trout River. And so what we did is we lined all of these riparian areas with the sediment retention barriers to prevent any of the fines escaping from the construction into the stream. Again, these cold water, clear water streams are very sensitive to turbidity. And you can see the SRBs there along the different rows. Again, we site tested the polymer to the turbidity that they were expecting on site to make sure we had something that was going to react with the soil. Here again are some more examples, just kind of rows and rows of these sediment retention barriers that we used. as kind of that final line of defense before the stream. We also soft armored the slopes that led down to the stream to collect some of the particulate. We didn't apply polymer to all of these areas. So one thing to note in this is in Michigan, we have a permit that we can apply for, which is a Rule 97 permit. In most states, and I think in the federal CGP, you are not allowed to apply flocculants directly to waters of the state. And you're also not allowed to, you need to collect the flocculant. So in this case, we were applying the polymer, essentially on the banks of these streams. And so we had to get a special permit. In most cases, we wouldn't be doing this, but it was a kind of special situation where and that's one of the benefits that I like to highlight is why we use PAM, anionic PAM specifically for these applications, because it has such a low toxicity that we can use it in these sensitive applications. So the turbidity would have a much higher, risk to these stream systems than the polymer that we're using to kind of solve that problem. So benefits of anionic PAM is that, it's not going to harm even, really sensitive aquatic organisms. So again, here's just a few more pictures of that soft armoring and those sediment retention barriers that we're using to manage any of the turbidity that's running off of that site. Really, really steep slopes. And we're really successful. There was not a lot of material moving off of this into that. So there was minimal erosion and sediment loss through the bridge construction. We didn't have no toxicity to aquatic organisms. We had another project up here in the UP where we did a culvert replacement and actually put the flocculants directly in the stream, again with a special permit. The treatment drain, a lot of times you're going to use, multiple things together to get best results. We also used it along the roadway here to help establish vegetation that you can see down there. And then the project was all done in compliance with specifically the Michigan rules and regulations as well. So with that, I kind of want to jump over to water treatment with the flock logs, or those solid gel logs that we've talked about a few times now. So again, just to recap how it works, the flock logs have to be placed in flowing water. All the water needs to come in contact with the flock logs. They're going to dissolve slowly. As the polymer dissolves, it's kind of a two-step process. The water is going to hit the log. It's going to erode and dissolve that polymer into the water. Once those long chain polymers are in the water, they have to physically contact the suspended sediment. That's why we need flowing turbulent mixing. And then that's going to have this snowball effect where we form these bigger and bigger particles until they're heavy enough to settle or be captured by, again, some type of fibrous matting or, polymer enhanced check dam or something along those lines. So I did want to recap the principles for effective flocculation with flock logs and flowing water. If, we test the material, we know we have the right formulation, and something is not working on an application, it's almost, 99% of the time, one of these fundamentals has not been met. So these are really, really important things to make sure we're familiar with. We have to have adequate mixing. Vigorous turbulent mixing in the channel is best. The more mixing, the better to form those big flocks so they can settle out. We need full reaction time. If you'll recall, what we do is we'll take a sample of the soil or water, we'll test it against a range of different flock logs or silt stop polymers. We'll see which one reacts. We'll also determine how long it takes to react. A lot of times we aim for about 30 seconds. So we need 30 seconds of flowing water to fully form those flocks before it, enters a basin or enters our particle capture area. So that's something to really be aware of. The other thing is the correct dosage. If we have a 500 gallon per minute channel and we put one flock log in that channel, we're not going to be up to dosage. So what we aim for is around 1 to 10 milligrams per liter. In a, actual useful application rate, that looks like about one flock log, which is about 8 pounds per 50 to 70 gallons per minute. In a flow through system, or if you're recirculating, we're going to use about 10 pounds per 300,000 gallons of water. A couple other things, we want to make sure that the flock logs are placed well in the channel and that there's no extra sources of turbidity that come in after our treatment system. So, if, say after this last wattle here, we have some sheet flow or some other, channelized source of turbidity, we're going to mask all the work that we just did at the top of that channel. In terms of placement, say we have a 10-foot wide channel and we put 2 flock logs in the center. Even if we space those 2 down the channel a ways, you can imagine how much water is moving past those that's not getting treated. So we really want to have flock logs spaced no more than about 2 feet apart, 2 to 3 feet apart. So we want horizontal placement across the channel, depending on how wide it is. And then we'll also have vertical, or not vertical, but placement down the channel as well. So we want to make sure that those logs are adequately placed so that all the water is getting some sort of flocculant dosing and mixing to get accurate treatment. So this was a channel at Auburn. I think we might have looked at this example last time, but this one is a good one. The channel is lined. There's no extra sources of turbidity. They've used flock logs and the siltstock granular powder together. They have used wattles and check structures to slow the flow, add additional mixing, collect the flocculated particulate. So they've kind of put all of these pieces together and are, very visibly having good results because of that. So this is a really well set up channel. Most of the logs are concentrated towards the front so that there's enough mixing and reaction time afterwards. So the flock logs are going to last until about 1 million gallons of water flow over them. And that can vary, depending on the temperature, how much particulates in the water, so how much wear and tear is on that log, the flow velocity. So it can vary. But again, one of the nice things about the PAM is that, we have a relatively we can use about 1 to 10 milligrams per liter, and we don't start to see, even, close to effects on aquatic organisms until we get, upwards of 70 to 100. So we have a lot of wiggle room for our applications, just due to the safety of the material. So last time we looked at a couple of basic types of mixing and introductory systems. So we have our open channels, closed pipes, open or kind of split pipes. We've used natural streams or waterways in very limited circumstances. We do the same with in-pond and lake treatments, as I mentioned, those pond logs. We can use existing stormwater structures. We can use mixing chambers and tank systems. So really, kind of the possibilities are endless with how we can introduce these flocculants to treat water, as long as we're meeting those fundamentals of flocculation. We're using the right formulation, we're using it in the right amount, we have enough good mixing, we're mixing it for long enough, and we're capturing that flock so that we're not sending the flock and sediment downstream. So we can do anywhere from, 10 gallons per minute up to, 10,000 gallons per minute, again, as long as we're meeting those fundamentals. So we'll look at a couple applications. This was just a demonstration scale, but we also, so for drilling and like pipeline applications. So we have a lot of turbid water that's coming out of those holes. And so what we did here is, for this demonstration in Pennsylvania, we had a sediment or grit pit to settle out the high solids. And this leads to an important point, is that the flock logs specifically are designed to treat turbid water. They're not going to treat mud. So if you, typically our rule of thumb is 4% solids, which I think is about 40,000 NTUs. So if we start to hit that limit, almost 95% of the samples that we get are somewhere in the hundreds to thousands of turbidities of NTUs. But if we get up to, tens of thousands, then that water will likely require either a pre-treatment or a pre-settling or a dilution before we can use something like a flock log, just because it's going to, take over those flock logs, and it requires such a high dosage to flocculate all that turbidity. So we want to settle out, heavier sediments if we can, using a settling pit like they did here. Then that water was pumped off the surface of that grit pit down our channel here that we can see in the center. And again, this was a small scale demonstration, so we had some smaller logs here, but it has all those same pieces, right? It has the jute lined channel where you can see a lot of that particulate's already attaching to. There's some rocks in that channel to increase the mixing potential. The channel is lined with plastic, so it's not running across the ground and picking up turbidity as it goes. And then in that picture 3, you can see the same water that came out of there after it was done and being released. So really, really effective, again, if we're meeting those fundamental rules. As I mentioned, we were going to go talk about the best way to use PAMs with dewatering bags. So dewatering bags are used very commonly with PAM. One thing I like to say, though, is that we have some people put them in the pipes as they lead into the sediment basin. That works some of the time. I will say that every project that I have been on that has put the flocculant into the pipe or hose that leads to the basin, those bags have clogged within 10 to 30 minutes and burst. So what can happen is the flocculant can kind of coat the inside of the sediment bag, and those flocks and the water can't move through and it'll burst the bag. So it really decreases the lifespan of the bag. Even though you might have crystal clear water running off for 10 minutes, nobody wants to be replacing a sediment bag, every 10 to 20 minutes. And so what we suggest doing is channelizing the water, either channelizing the flow to use flock logs coming out of the sediment bag, or using the silt stop with wattles or matting to treat sheet flow out of the bag using that soft armoring technique. And so really, I would strongly suggest always using the flocculant after a sediment bag. Again, sediment traps and basins, I think we talked about this quite in the first presentation, but these are already set up for flocculants. If we have a channelized conveyance that leads into a basin, we can treat that water as it moves in. And again, following those rules, we're going to put the logs kind of closer up the channel. So we don't want to take a flock log and put it right as the water discharges into the basin, because we will dissolve flocculant into the water, but we won't have enough time or mixing to react it. And so it's not going to do anything. And we're just kind of essentially washing polymer off our site. So one thing that we see a lot that's really beneficial, especially if we have fine particulate, is to use baffles in the basins, especially if they have things like the core material that they're made out of, because they can capture flock. So that can be a really great way to capture flocculated particulate as well, especially, we like to have every application have a 20-second reaction that creates, giant flocculated particles that immediately settle out of the water. That's not always the case. Sometimes we have very fine, fluffy particulate, either just because it's a challenging soil. Maybe the water is really cold. Maybe we don't have a lot of mixing and reaction time to get the flocks big enough. In those cases, if we can implement additional particle capture, with baffles, that's always a great application. So in this one, again, these flock logs are probably too close to the end of that channel. We want to make sure they're higher up the channel so that we have enough mixing and reaction time so that they can settle out in the channel. Okay. So I think we went over these a little bit too, but we'll go through pipe mixing systems. So pipe mixing systems are really great if you don't have a lot of space. You need to move them around your site. So we also need to make sure, again, with these pipe mixing systems, that we're getting enough mixing and reaction in the pipes, and we're also capturing the flocculated particulate. So here, each one of these Y cleanouts down these hoses has a flock log in it. And so the way they get up to dosage is they put multiple flock logs along that hose, and then they're capturing the flocculated particulate at the end of this on that jute matting. These can be done in a lot of different configurations. They always consist of a pump, some way to dose the system, and then enough mixing and reaction time, which might look like, 100 to a couple hundred feet of hose to finish forming those flocks before you discharge. Other really kind of simple way to use the flocculants is a open pipe mixing system. So you can use split pipe, you can use an existing channel if you have it. And this is, we like the open systems best if we can manage that, just because they're a lot easier to adjust to get enough mixing, enough reaction. The water velocity is not quite so high. Closed pipe and under pressure systems can be very effective too, but if you can manage an open system, it's just a little bit easier to deal with. Here's another example of a split pipe system. These work great if you're kind of in, more of a urban or industrial area, because you basically can very quickly assemble a channel. You can see in this one, they again use sandbags with jute on top as kind of their check structures, and we have the flock logs below those as the water flows over. So can't get enough jute matting and mixing material. Existing stormwater structures, that's another good one. So if a lot of times, maybe a project's in a phase where we don't have open, maybe everything's buried. So we can put them in storm drains and pipes that lead to basins. And these can get relatively large. So we did a airport expansion. It was a $75 million basins. They weren't able to meet the charge limits. And so we used their existing conveyances that they had installed for stormwater. In this case, it was a 6 minute, like 5-foot diameter pipe. And so you can see there was probably maybe 24 flock logs tied together in that pipe. But again, we had enough mixing, we had enough reaction, it was the right formulation. And so they were, doing this on a much larger scale than the pictures that we looked at a minute ago. And what happened is after they discharged that water, they had a series of jute particle curtains to aid in additional particle capture downstream of that. So with that, I just want to finish up. We've looked at a lot of different types of applications. And so for the water treatment ones, we'll go through a couple short case studies that kind of highlight those applications. This was a roadside pond, small project down in Florida, turbidity from redoing the road that was adjacent to the pond. So this pond in particular, I think it had a turbidity just over 100. Sometimes when it's a lower turbidity, it's actually harder to treat. There's less particulate to form those big flocks. And so sometimes the lower turbidity ones can be more challenging than something that's, 500, 600 or a couple thousand NTUs. So again, to start every project, we always start with a jar test to determine which form of the polymer is most effective. So you can see again on the left-hand side, there's our untreated. We found a flocculant that was a good match, reacted, and settled those out. Final turbidity in our sample analysis was 13. So we always, when we do our sample analysis, check the pre and post turbidity so we can get an idea of if we set up the application well, what type of results we can expect. So this, it worked well on this project that they could just excavate a trench and line it with plastic. Again, if you didn't line that channel, you would just be causing more erosion and more turbidity as you started pumping the water. So really important to use a lined channel or lined treatment area with no outside sources of turbidity after our flocculant. They also lined it with jute. We've talked a lot about jute. We can't use enough jute with the flocculants, and put the correct form of the flock log down the channel. You can see the blue logs there on the left picture. And then they have some probably jute, but also that aids with mixing. And as before, really down in Florida, some turbidity. In many cases, we have to get it below 32, depending on the body of where we're going to be discharging. So especially when we strict turbidity or numeric limits, We will use the flock log with the granular. Again, that's always going to give us our best results. So we try to stress to use those together. And so here they were adding the silt stop powder to the jute matting as well downstream of those flock logs. So then what they did is they pumped the water. This was a recirculating setup. So we can, do flow through where we treat and release. We treat the water, we collect the particulate, and then it continues to move downstream. In this case, particularly, we did a recirculation application. And then when the pond was at the level we needed, we were able to discharge. So they pumped the water through down this treatment channel. A short video. I think they were doing about 300 gallons per minute. So the water's flowing out over and around those flocculant logs. Let's see, good question. So this is a good question. I'm going to see if this will keep playing. The question was, after an application and a successful treatment, would you attempt to remove the flocks after they settle or leave them? And so what we would do is, so say we have a sediment basin on a project, you would have to, manage and clean out that basin as, whatever your design standard was for that. I think it's usually at 50% capacity, you have to clean out a sediment basin. Don't quote me on that. Basins aren't my specialty, but I'm pretty sure. So basically you would just maintenance that the same. There's no special disposal considerations for anionic PAM. It's not hazardous. So a lot of times when we have maybe saturated jute matting that has all these flocculated sediment with the polymer, we like to tell people to take those and use those for erosion control on other areas of your site. If you clean out a basin, now you have this polymer treated sediment. Use it as
Kyla, we just lost your audio. I don't know if you can hear me. I'm sure she will pop back on here in just a sec as soon as her connectivity gets reestablished. So what does everybody think about this product so far? Have you seen it being used in your communities yet? Definitely don't all unmute at the same time. Go ahead, Solomon. I see you unmuted. Oh, Season hasn't seen it. Chow, I think we're gonna actually be able to share this recording, but if we get her slides as well, I can certainly send those out as well. Trish, were you gonna say something? I think you unmuted as well.
Yeah, we've seen it used. We tried it on a couple different subdivisions. But talking to a couple people, I think we had it mixed wrong. And it worked for like one rain maybe, and then it just didn't stay put. So I've been talking to OSU and them to see I think we probably just we didn't test it ahead of time, the soil, and that's probably where we fell short, was not actually testing the soil. We just followed the instructions on the bag. So we may try it again. I'm not sure, but we have seen it. We just haven't seen it lately.
Okay.
Hey, Rebecca?
Yeah, hey, we've just been chatting. We lost you there. Figured
I
you'd be
can't, I
back.
can't get back on. My Zoom crashed and I cannot get back on. So I apologize. I had one more case study to go through, but after that I was pretty much wrapped up anyways. So did you hear the answer to my last question about reusing the flocculated material, and that if it's not able to be reused, that it's not hazardous and there's no like special disposal considerations?
Right. Well, I think we heard that part. If there's
Okay.
anything else that you wanted to add to that, feel free. But
No,
then,
that was
okay. But yeah, anything after that we did miss. And then we have some more things in chat if you want me to go through. One person asked to share the slides, and I did mention that we are going to have this recording available as well. But if you don't mind sending your slides, that'd be great as
definitely.
well. And then I asked everybody if they've seen anything used in their communities yet, because we do have several different municipalities represented here and other organizations, and got a couple folks that said that they haven't seen it. And then one person said that they purchased some flock logs recently to try them out. They've had a few sites try granulated with mixed results. So be interesting to kind of dig into that and see if there was a way to
Yeah,
get that
be great.
addressed.
Yeah, because I'm sorry to hear there was mixed results. But one thing I did want to share with us, one thing that we do daily on a regular basis is we work very closely with people on their projects. So not just designing the application. So if you let us know what's going on at your site, especially if there's any pictures, and especially if you've tried an application and it hasn't been successful, we're here to help. So if there is pictures of the site, we would like to make sure that there's the right formulation. We want to make sure that we're using the right amount. Sometimes small changes to where it's applied or how it's applied. So we are, if something doesn't work, we're here to help make adjustments and get it going. So I'm actually glad that question came up, because sometimes we hear that and it's like, well, we didn't hear from anybody, we can probably, make some adjustments and hopefully get it working successfully. So
Cool. Thank you. And Catherine added, they haven't seen it either. She's actually with our Oklahoma Department of Transportation. They
Okay.
have a conference coming up. Do you guys ever do any Oklahoma conferences?
I don't think we have done an Oklahoma one recently, but we do conferences. We've got 4 of us that travel pretty extensively for conferences, so we're always open to different events, especially if there's an interest. So
Okay. Catherine, if it's all right, I will get you Kyla's information and you guys can swap info, and if it works out, that'd be great if they can attend your conference. Great, thank you.
thank you.
Yeah, so we've got a lot of people who are interested in seeing it used, people who have tried to dip their toes in the flocculant water, so to speak. So maybe we can get some more takers soon and see if we can get some success stories for you here in Oklahoma.
No, that sounds great. And and I also think we can do the virtual presentations and conference presentations are great. I don't want to say that flocculants are rocket science, but there is a learning curve, and just some minor adjustments can kind of make the difference between success and failure. So we're always open to like in-person like demo events as well, because I think those are those are probably one of the best ways to convey and show people how to correctly implement the flocculants. We've done that in a few different states. So if you ever, have any, desire to set up um, a demonstration day or something like that, we're always open to that as well. Because I think that that's definitely the most bang for your buck in terms of teaching people to, properly set up and use the flocculants.
Right. So Catherine might be able to answer this question. I wonder if C4, the conference that she's in kind of helping with, I wonder if they would have a spot for you to be able to do a
Oh.
demonstration.
You know what?
Yes.
All right, we're there.
Oh, great.
Oh, okay.
We are there. We have never done it before. But Hal Lunsford works with us, and I'm
Oh,
not doing it
perfect.
personally, but I think we just signed up about a month ago, so we're actually going to be there.
Oh,
So that's perfect.
that is perfect. Excellent. And then I wonder if you guys are going to be here. I wonder if we could maybe set up for people that can't attend C4. I wonder if we could set up another demonstration site like the next day or something like that. I don't know if he's going to be spending the night, if that would work out. I don't know if he's already got his travel set up, but we might try to swap some notes later and see if we can coordinate something for people to attend as well.
Yeah, that sounds great. We would definitely be willing to do something like that.
Cool. Great. Any other questions from our audience? Well, while this wasn't a traditional ending to a webinar, thank you, Kyla, for
Sorry,
popping back
I don't know what
on.
happened,
Gosh,
but yeah,
we certainly understand technical
yeah.
difficulties, they happen. So, but yes, thank you so much for your time. And if anyone else ends up with any questions, feel free to email me and I can get Kyla's information out to everybody. And Kyla, were you going to do the certificates again this time for us?
Yes. And so as long as if I have the email address, and those will come out from Certifier. And then if somebody doesn't get them, because I feel like, I don't know, I think with the program, it can get spammed occasionally. So if you don't get it, just let me know and I'll reissue. So.
Okay, great. Well, I'll get you those email addresses and names, and thank you so much.
All right. Thanks a lot.